Hi grade 9s, we are on Unit 3, Day 2, and in today's lesson we're going to look at solving multivariable equations. So before we get started, I want you guys, if you are either have the lesson note printed out or are looking at the lesson note online that's linked in the outline, I'd like you guys to pause the video for a minute and try the 6 questions in the warm-up. So that is something that we would do at the start of class to really make sure that you guys understood the work from your day 1 note before you moved on to the day 2 lesson here. So we're going to be talking about more complex equations where there's more than one term with the variable. And I want you to make sure that you can do those 6 warm-up questions. So pause this video now, go off and work through A to F on the warm-up, and just wait and then unpause the video and double check your solutions. So I'm not going to go through every solution here, but I'll just kind of highlight some important ideas, and this note is scanned in and linked in the outline as well. So here you've got 6 different equations to solve, and it kind of runs the gamut of the very simple, like 1-step equations that we started with, up to the 2-step equations, multi-step equations with fractions. So double check your answers. You should get x equals -8 when you undo multiplication with division. W equals -40 when you undo the division with multiplication. Here, watch out when the variable's on the right-hand side of the equation. That does kind of mix people up sometimes. I undid the -3 with a +3, and then undid the multiply by 4 with a divided by 4, and got y equals 5. The next one, I've got, it's kind of a fraction, but we can undo that division with multiplication at the end. It's not too bad. I'm adding 6 to undo that -6, and then multiplying by 4 to undo the divided by 4, and I get m equals 96. Another one kind of similar to when the variable's on the wrong side, although there isn't really a wrong side. When the variable's on the right, that sometimes mixes people up. This one, the variable's on the left, but it's written in a different order than what we usually see. So just be careful that this negative sign in front of that 6, it's connected with the 6. It's a -6, -6. So I have positive 15, so I have to undo that with a -15. And then I still have -6a equals 12, which is the answer, and undo that -6 times a with a divide by -6. So I get a equals -2. The last one, I chose to do this just with fraction operations, but you could do it by multiplying through by the lowest common denominator, which would be 6. But this is like method 1, like we talked about yesterday. So I brought this plus 1/2, undoing that with a -1/2, which got me 12/2, which is just 6/1. And then here I have multiply by 2/3, so I undid that with a divided by 2/3. Remember, when you're dividing fractions, you have to flip that and multiply. Multiply tops and bottoms is 18/2, or just 9. So that's the warm-up. Make sure that you got those. If you didn't, then please go back and double check through the day 1 lesson, or email your teacher and make sure that you're confident in this material before you move on to the day 2 work. So here is an example. We have the perimeter of a triangle is given as 28 units. We want to find the length of each side. So we don't have an equation to solve, but we know that we're working with equations, and we also know that perimeter is all 3 sides of a triangle added up together. So I'm going to form an equation with that, because I know this side plus this side plus this side would equal 28. So I'm going to use that to build an equation. 3x minus 1 plus, maybe put some brackets here, 5x plus 3 plus 3x plus 4 equals 28. Now, remember in the previous unit, we had expressions like this, right? And we added up our polynomials. We looked for our like terms. When there was a plus sign in front of the brackets, we didn't have to do anything or change anything. So 3x minus 1 plus 5x plus 3 plus 30x plus 4 equals 28. Now I'm going to kind of highlight my like terms. So I have a 3x. Which other terms have just an x with no exponent on it? 5x and 3x. So 3x plus 5x plus 3x. Remember, we add the coefficients and keep the variable part the same. So 3 plus 5 is 8 plus 3 is 11x. And then we will look at our other like terms, which is just our constant numbers. -1 plus 3 plus 4. So -1 plus 3 is 2, plus 4 more is 6. So I get plus 6, and that's equal to 28. This looks like a small, nice equation that you guys were solving yesterday. So here we've got 11x equals, undo the plus 6 with a minus 6, 28 minus 6. So 11x equals 22. And then I'm going to undo the multiplication by 11 by dividing by 11. And I get x equals 2. So that feels like the answer to this question. But make sure you're reading carefully. It says, find the length of each side. Is x equals 2 the length of each side? It's not. I have to use x equals 2 and actually figure out what the 3 sides are. So I'm going to my first side, 3x minus 1. If x equals 2, I'm just going to sub a 2 in there. 3 times 2 is 6 minus 1, which is 5. And then the next side, 5x plus 3. So 5 times 2 plus 3. And then 5 times 2 is 10, plus 3 is 13. Good stuff. And then the last one, 3x plus 4. So 3 times 2 plus 4, 6 plus 4, which is 10. So I could do a check. Is the perimeter 28? 5 plus 13 plus 10, yeah, it is 28. And because this is a word problem, therefore the side lengths, I have to write a therefore statement, are 5, 13, and 10 units. It doesn't say centimeters or meters or inches or anything, so I'll just say units. So that's a good example of a word problem that you could have to solve using our solving equations skills. Now, we're going to start solving equations, and the difference in today's work compared to the day one is if you look at this equation, I have y's, my variable, in different spots. That's what we mean by a multivariable equation. You've got variables in more than one location in your equation. And this is going to be our strategy right here. We're going to move all variable terms to one side. I'm almost always going to pick the left side just because I think that's where most people default to, but it doesn't have to be. And all constants to the other. So in general, we want to get all of the variables onto the left and all of the numbers onto the right. Or you could swap around that left and right, but generally people go variables to the left, numbers to the right. And to do that, I have to do opposite operations. So the first thing I'm going to do is I want this 5y to be over on the left-hand side. I can't just cross it out. I can't actually just move it. What I can do is undo my operations, do opposite operations. What could get rid of 5y here? I could subtract it. I could do minus 5y. If I subtract it, I have to do that on the other side. So I've got 28 minus y minus 5y. And again, I'm going to write out more steps than what I normally would for the first example. So I've subtracted 5y from each side, and that keeps my equation balanced. I would get a 0 pair here. 5y take away 5y is just 0, so I don't have anything there. So here I get 28 minus y minus 5y, I'm not going to simplify anything yet, equals negative 2. Now, I want to get rid of the 28 that's on the left-hand side. I have to subtract 28 from both sides. So I'm going to say 28 minus y minus 5y minus 28 equals negative 2 minus 28. And this, again, is showing way more steps than I normally would. This is not how I'm going to solve each one, but it's to kind of show you what we're doing. So I've subtracted 28 from each side. 28 and minus 28 are a zero pair. They're gone. 28 take away 28 is gone. And here I get negative y minus 5y equals negative 2 minus 28. Now, normally I would skip right to this step. I wouldn't actually show these 3 steps up top, but I want you to see what we're actually doing. So we're normally going to go right from the question down to here. So just kind of a one-time thing to show you what we're actually doing. We can move things by doing the opposite operation, okay? Move terms. We're not actually moving them. We're just doing opposite operations in a balanced way and not showing, eventually not showing where we have 5y minus 5y or 28 minus 28. We're going to kind of shortcut that. So again, there's no such thing as actually moving things around, but that's what it's going to end up looking like when we do these opposite operations and start skipping over some of these steps. So here I have like terms on the left, negative y, remember that's like a negative 1y, minus 5y is negative 6y, and negative 2 minus 28 is negative 30. Now I can divide both sides by negative 6. And get y equals 5. So that's my solution. This is a lot longer if we kind of look through all of the steps than what we're really going to end up showing in most of these questions. Okay, so I'm going to do the next one not showing all of these steps. So for B, I have 18 plus 3x minus 5 equals 65 minus x. If I know I'm going to want this x over on the left-hand side. To get this x on the left-hand side, I don't want it over here, so I have to get rid of it on the right-hand side. I would get rid of a minus x by doing a plus x. That would be a zero pair. I'm not going to write it out over here. I am going to write it out where it ends up when I do the plus x on the other side. So I have 3x plus x. And I know I want to get rid of, quote unquote, get rid of 18 and minus 5. I have to do opposite operations. To get rid of a positive 18, I have to subtract 18. I would do minus 18 here and it would zero pair. I would do plus 5 to get rid of a minus 5 and that would zero pair. But I'm not going to show it on the left. I'm just going to show minus 18 and plus 5. So these are the opposite operations that would have happened over here. And I'm just not showing each one. So then I've got a much simpler equation. 3x plus 1x, or just x, is 4x. So 65, take away 18, plus 5, we've got 52. And then dividing this by 4, to undo the multiply by 4, we get x equals 13. So again, this is kind of what we're going to end up showing, but the way we're moving, and people say that they're moving stuff around in an equation, what you're really doing is just those opposite operations that we're just not showing them all. So maybe I'll show them kind of back up here with how I would get here. I don't want an 18 here, so I'm going to put like a minus 18 and a minus 18. These ones are going to reduce, so I only end up showing that one, right? I don't want a minus 5 here, so I'm going to put a plus 5 and a plus 5. These ones reduce, so I only end up showing that one. I don't want a minus x here, so I'm going to put a plus x, and I'm running out of space. This is why I don't do this. And a plus x, and these ones reduce, and that's why I only have 3x plus x over here and 65 minus 18 plus 5 over here. So that's kind of where this comes from, but you don't have to show this work if you're comfortable moving right to this step. So for part C, we have 8n plus 4 plus 2 equals 3n minus 12 plus 2n. So if I'm looking at getting the variables to the left, I have an 8n on the left. I'm going to keep it there. Plus 4 and plus 2, I know I'm going to want to eliminate from the left side and get them on the right side. What stuff from the right side do I need to get to the left side? I need to move this 3n, and I would do that by minus 3n on both sides. The one here would 0 pair, but I'd end up with a minus 3n on the left. Minus 12, that's where it wants to be. It's a number term on the right. And then I have a plus 2n, and I would want that to be over here too. So I'd have to do minus 2n here, which would 0 pair, but I'm not going to show it. And then I get a minus 2n over there. Then thinking about my numbers, I have a negative 12. Remember, the sign in front sticks with the number that immediately follows it, negative 12. And then over here I had a plus 4 and a plus 2. I would have to do minus 4 to 0 pair them out over there, and minus 2 to 0 them out on the left, and I'd end up with a minus 2 on the right. Now I can do my like terms, 8n minus 3n. So remember, add and subtract coefficients, keep the variable the same. So that's 5n minus 2 more n is 3n. Negative 12 minus 4 minus 2 more. So think about your number line. Negative 12 minus 4 is negative 16, minus 2 more is negative 18. So you'll see these equations are actually pretty short to solve once you get in the hang of it. And then we've got 3 times n. We can undo that with division. Oh, positive 3. And then that reduces, and we get n equals negative 6. So all of these kinds of questions in today's work are going to follow very similar example to this. The last one is a thinking kind of question. And we are going to set this up using an equation. So you'll see a number of kinds of geometry questions in particular that you can use equations to solve. So this says rectangle DEFG. So this is the big outside rectangle, has a square. So this guy is a square, ABCD. I'm going to label these sides with those tick marks that mean that they're all equal. It has a square removed. So this square has been taken out, and it leaves an area of 92 meters squared. So the stuff over here, if you cut out this square in the corner, we're left with 92 meters squared over there. Okay. Now I'm going to start labeling some other stuff that they tell me. Side AE is 4 meters. And side CG here is 8 meters. Okay. Determine the original area of rectangle DEFG. So the big rectangle, what was the original area? So basically, we want to find out how big this square was that they cut out. Whenever I want to find a size of something, I like to put a variable. So I'm going to label that with an X. So I'm going to say, let X equal the length of the square, the side of the square. So now I need to figure out a way of representing this 92 as all of the pieces of this added up. I'm going to kind of color code this and divide this up in there. You guys probably have seen by now that I really like color coding things. And then I've got an orange, and then need some more colors. Let's make a purple. Okay, so does it make sense that the pink plus the orange plus the purple will add up to 92? Hopefully it does. Now, the orange one, I think that's the easiest area to find. That area will be 4, because this is 4. So that's 4. And this across here would be the same as that. So this would be 8. So this area will be length times width, which is 4 times 8, which is 32 meters squared. I colored these in a little bit too well. So that's 32 meters squared for that orange one. Okay. So then if I look at my pink one, I have 4 here on the outside. And what would be across here for length and width? I know my square is x, so that's going to be an x. So here I'm going to say area is 4 times x, or just 4x. And then that's going to be real similar to this purple one, because I have an 8 this way and an x this way. So the area here is 8x. Now remember I said pink plus orange plus purple equaled 92. The 92 was this whole big kind of L-shaped thing. So that's what I'm going to use as my equation. The pink area, which is the 4x, plus the orange area, which is 32, plus the purple area, which is 8x, that all equals 92 meters squared. So there's my equation. I'm going to do something here. I'm going to add up my like terms, and you don't have to do that before you start working through an equation. In the examples in the earlier part, I didn't, but I do think that it might kind of make it easier for you guys to see. 12x plus 32 equals 92. And now I'm going to solve this equation. This is like one from yesterday. So 12x equals, I'm going to subtract 32 from both sides. So I get 92 minus 32. 12x equals 60. And then 12 times x, I can undo that by dividing by 12. And I get x equals 5. So my whole original area was 92. The square, or this L-shaped area, all added up to 92. The square is going to be 5 times 5, which is 25 meters squared. So then the total, remember they didn't ask us for how big the square was. They said the original area before you cut out the square. So I'm going to take this 92 for what was left and add in the 5 times 5 is 25. 92 plus 25, 117 meters squared. And it is a word problem, so I have to write a statement. Therefore, the original area was 117 meters squared. So that is it for your day 2 note. We will be kind of continuing on and talking about solving equations with more different polynomial operations in day 3. So you guys are all set to work on your day 2 homework and then move on to the day 3 lesson.